Welcome back! In this lesson, we will explore the fundamental differences between discrete and continuous variables and how they shape our statistical analysis. Why does this matter? Imagine we analyze a student transcript and record 3 values: the course title, their letter grade, and their percentage score. Although they all describe performance, they belong to completely different scales. How do these properties change the way we do math? First, let's look at qualitative scales. Nominal variables, like course subjects, represent categories with no mathematical order. Ordinal variables, like grades A and B, also group data, but they carry a clear relative ranking and direction. Next, we have quantitative scales. Interval scales have arbitrary zeros, like 0 degrees Celsius, which doesn't mean a total absence of heat. In contrast, ratio scales have a true physical zero, meaning 0 represents a complete lack of the quantity. Because ratio scales have an absolute zero, we can compare values using division. We calculate the multiplier, capital R, by dividing the score of subject, A denoted as X sub A, by the score of subject B, denoted as X sub B. This gives us a direct physical comparison. Let's run worked example. If student A scores 80% and student B scores 40%, we divide 80 by 40 to get a multiplier of 2. Since percentage score is a ratio scale, we can correctly state that student A's score is exactly twice as high as student B's. In worked example 2, we compare vehicle speeds, 120 kilometers per hour versus 60. Dividing the two speeds gives a multiplier of 2. Since speed has a true physical zero, this calculation is valid, and we can say that car A is moving twice as fast. Now, let's understand numeric structures. Discrete variables represent countable values with distinct gaps. For example, the number of website visitors must be an integer like 1, 2, or 3. You cannot have 2.5 visitors. Conversely, continuous variables represent measurements that can take any real value on an interval. For instance, the amount of water a person consumes is continuous. It can be 2.3 liters or any decimal in between, forming a smooth range. All these scales fit into a clean measurement hierarchy. Starting from nominal at the base, each level inherits all mathematical properties of the levels below it, with ratio scales holding the most mathematical power. Let's highlight a common mistake. You must not calculate multipliers on subjective ordinal ranks. Stating that a very satisfied customer at Tier 4 is twice as happy as a dissatisfied customer at Tier 2 is mathematically invalid. Instead, compare their relative ordering. To summarize, discrete variables represent counts. Continuous variables represent measurements. Nominal and ordinal describe qualitative categories. And ratio variables require a physical zero to compare proportions. Thank you for tuning in to Topical Brew. Keep practicing, stay curious, and make sure you're subscribed with notifications turned on so you're ready for our next topic. If a concept felt a bit tricky today, or if there's a specific challenge you want me to break down in the next video, let me know in the comments.